In this video, we're going to look at the x and the y-intercepts of a line. These are the points or the ordered pairs where the line crosses the x-axis and the y-axis. Since an x-intercept is a point on the x-axis, it must have a y-coordinate of 0, because any point on the x-axis has a y-coordinate of 0. So to find an x-intercept, we set y equal to 0 in the equation and solve for x. A y-intercept is a point on the y-axis, and any point on the y-axis has an x-coordinate of 0. So to find a y-intercept, we set x equal to 0 and solve for y. Let's try that in this example. Here's the equation of our line, and we're going to construct a table of values to find these intercepts. Remember that we start with an x value of 0 and solve for y to find the y-intercept, because this will be an ordered pair on the y-axis. So let's plug an x value of 0 into this equation and solve for y. 5 times 0 is equal to 0, so we're just left with 3 times y is equal to 10. And now we divide both sides by 3 to isolate y. That leaves us with y is equal to 10 over 3, or 10/3. So we have the ordered pair x is equal to 0 and y is equal to 10/3. And that'll be a point on the y-axis, because we'll have x equal to 0 and y equal to 10/3, which is 3 1/3. Now let's substitute y equal to 0 to solve for the x-intercept. 3 times 0 is equal to 0, so we're left with 5x is equal to 10. And we divide both sides by 5 to isolate x. So x is equal to 10 over 5, or 2, when y is equal to 0. And this ordered pair, 2, 0, will be 2 units to the right on the x-axis. So that is the x-intercept. Let's plot those two ordered pairs and sketch our graph. Here I've approximated y is equal to 10/3, or 3 1/3, just a little bit above 3 on the y-axis, with an x-coordinate of 0. And here we have x is equal to 2, y is equal to 0. So these are the two intercepts, the points where the graph crosses the two axes. If we wanted to be more sure that we got these correct, we could plot a third point and make sure that it falls on this line. Or you could double check these ordered pairs by substituting the values into the equation and make sure that they are solutions. Let's look at another example. Here we have another equation of a line, two variables with exponents of 1. This equation also has the y isolated on the left side, but we can find the intercepts the same way we did in the last example. So let's start by making a table of values, with one ordered pair having x equal to 0 and another ordered pair having y equal to 0. Starting with the first ordered pair, we'll plug in a value of x equal to 0 in this equation. 9 times 0 is equal to 0, and we're left with y is equal to -6. So when x is equal to 0, y must be equal to -6. And this will be a point on the y-axis, and that makes it the y-intercept. Now to find the x-intercept, we'll substitute y is equal to 0 in this equation, and we'll solve for x. So here we'll have to solve by isolating the variable. Let's add 6 to both sides to cancel the -6 here on the right. That gives us 6 on the left and 9x on the right. And now we can isolate the variable by dividing both sides by this coefficient of 9. That leaves us with x on one side is equal to 6 over 9 on the other side. And 6 over 9 can be reduced to 2 over 3 if we divide top and bottom by 3. So when y is equal to 0, x must be equal to 2/3. And this will be a point on the x-axis with an x-coordinate of 2/3 and a y-coordinate of 0. So that's the x-intercept of this line. Let's go ahead and plot the two ordered pairs and sketch the graph. The first ordered pair, 0, -6, is the y-intercept, and the second ordered pair, 2/3, 0, is the x-intercept. And I approximated the value of 2/3 between 0 and 1. So this is the line given by this equation, and these are the two intercepts.